Every time a vehicle moves, there's a critical component working behind the scenes to transfer power efficiently: the drive shaft. From early steel designs to today's advanced composite materials, the drive shaft has evolved significantly, improving performance, durability, and efficiency. The fundamental role of a drive shaft has remained unchanged. It transfers torque from the engine and transmission to the wheels. However, the materials and engineering behind this component have advanced considerably. Before the 1980s, drive shafts were primarily constructed of high-grade steel. And while durable, these drive shafts were heavy, which impacted vehicle efficiency and performance. In 1985, the first composite drive shafts were brought to market. Ford introduced them for the E-Series Econoline vans, and GM followed with the C4 Corvette. These new materials, including aluminum, carbon fiber, and Kevlar composites, significantly improve strength-to-weight ratios, allowing vehicles to handle higher torque loads without added weight. Today's composite drive shafts offer improved performance, better durability, and enhanced vehicle dynamics. However, like all mechanical components, drive shafts wear out over time. Here are some tips to help identify a failing drive shaft before it causes major issues. A failing drive shaft doesn't always fail catastrophically. It often gives warning signs. Let's break down the key symptoms. One of the most common signs of a worn drive shaft is excessive vibration while driving. If a drive shaft becomes imbalanced due to wear, impact damage, or improper installation, drivers will feel noticeable vibrations, particularly at higher speeds. These vibrations can also lead to premature wear on other drivetrain components. Another telltale sign is a clunking or knocking noise when shifting gears or accelerating. This typically indicates worn universal joints, or U-joints, which connect the drive shaft to the transmission and differential. Worn U-joints can also create excessive play in the drive shaft, further accelerating wear. If a test drive reveals a shudder when accelerating from a stop, it's likely due to improper drive shaft alignment or a failing center support bearing in a two-piece drive shaft. Ensuring the drive shaft is properly phased and aligned is crucial to avoiding these issues. A high-pitched squeaking noise while driving can also indicate worn U-joints. This noise is often caused by a lack of lubrication, leading to metal-on-metal contact that worsens over time. Regular maintenance and lubrication of U-joints can help prevent premature failure. If a vehicle exhibits any of these symptoms, a thorough inspection is necessary. Here's a step-by-step guide to help make an accurate diagnosis. Step 1. Perform a visual inspection. Look for visible damage, such as dents, cracks, or bends in the drive shaft. Check U-joints for rust, excessive play, or missing clips. Inspect the center support bearing, or two-piece drive shafts, for wear or excessive movement. Step 2. Conduct a road test. Listen for clunking or knocking sounds while shifting or accelerating. Feel for vibrations or shuddering, particularly at higher speeds or during acceleration. Step 3. Check drive shaft balance and alignment. If the drive shaft was recently replaced, verify that it is properly phased and aligned. If imbalance is suspected, consider having the drive shaft professionally balanced. When it comes to a complete job, proper installation is critical to ensuring long drive shaft life. Always follow manufacturer guidelines, use correct torque specs on fasteners, and ensure proper phasing on slip-yoke drive shafts. Misalignment or improper installation can lead to immediate failure or premature wear. And remember, safety first. Always ensure the vehicle is securely lifted and supported before working under it. Understanding drive shaft evolution and knowing how to diagnose a failing drive shaft can prevent costly repairs and keep vehicles running smoothly. Stay ahead of potential issues and always inspect drivetrain components during routine service. For more information, visit TrakMotive.com.